Last lesson you just did was how things grow, how living things grow, population, bacteria, chemical isotopes, okay, how those things grow. Our last two lessons are both going to deal with how money grows. Today we're going to focus specifically on interest, where your money grows. On Monday we're going to focus how your debt grows. Okay? So we'll do both. So this is the positive day, and then on Monday is the day where, you go into debt. Most of you are just about ready to assume the largest amount of debt you've ever had as you get ready to take your student loans for college. Okay? All right, here we go. Right. We're going to talk about how money grows in 3 different ways. So there are 3 different formulas. They will be part of a formula bank that you get for the quiz, test, and final, but they won't be labeled, so you'll need to know which one is how to use each one. Yes, the bargain can be, I won't give you a formula bank. All right, here we go. First one. The first way money grows is by what's called simple interest. This is the most basic form of money growing. It grows once a year. You put money in, and at the end of the year, you get your interest back. Okay, so it grows in the way that interest is given once at the end. All right, so that's what makes it simple. It's a one-time transaction. You put your money in once, you get your money back once at the end. That's what makes it simple. Its formula is also the simplest formula. A stands for the amount you get back. P sub 0 stands for the amount that you put in, okay, your original principal amount. 1 plus, so far it looks a lot similar to what we did with how things grow. 1 plus R. You never want it to be 1 minus R. That would be a bad situation for you. Okay, that would be called the Great Depression. So we want 1 plus R. And then we have time. And this is the most simple place where time is. It just goes right next to R. So that is the simplest formula that we've got for how money grows. The most common form is something called compound interest. This is what most bank accounts are. If you ever listen to radio commercials or TV commercials about investing, TD Waterhouse or any of these other companies, and at the end, somebody's talking really, really fast and saying a lot of things like investments, how much they were showing you know how they say all that, they by law they have to squeeze it in there. Okay, so they're telling you what the percentage rate and what all the details are. So here's the details. Compound interest is given more frequently. So the interest is awarded frequently. Now that frequency can depend on the the terms you sign with your bank, but it could be monthly. It could be semi-monthly, twice a month. It could be weekly. It could be quarterly. It could be every other month. Whatever terms you come up with the bank. That's more of a common thing for them to have, and it goes vice versa. Then if you have to pay them back at the same frequency. So the formula for that looks like this. A equals P sub 0, 1 plus. So you start to see that it all kind of, again, starts out looking the same. The difference is right here. The R has to be divided by the number N, and the N is that frequency. It's the arrangement you make with your bank of how often this is going to happen. So if you guys arrange that it's going to be once a month, then that N is 12. If you arrange it's going to be every other month, then that's only going to be 6. It's going to be every week, it's going to be 52. It's whatever you and the bank decide. Okay? And then the time is up in the power. and it's multiplied by that same n. So it's the agreement that that n frequency. The most complex is called continual interest. And no bank wants to do this because it's really good for the person, the small person. It's really bad for a bank. So most banks will not offer this as an option. You can get really lucky and you find it. Continual interest. Whoops, I just realized I didn't spell frequently right. I wrote frequency. Yeah, frequent. Lee. Thank you. Grace. You guys give me grace. All right. Okay, and in this case, interest is given every moment, second of every day. Okay, that is always being awarded. And what's good about this is because every time you get interest, the more often you get interest, well, if you get interest early, well, then that interest can earn interest. And then that interest you get the second time, that can earn interest. And so if they're giving it to you continually, every second of every moment of every day, okay, you're going to accumulate interest a lot faster. That formula is A equals P sub 0. And now is when we use E. And then R and T are up here. So this is the only equation that has E. So one equation has E. This is the PERT equation that you learned last year in Algebra 2. One equation has N, and then the simple one doesn't have either E or N. Okay, those are the three. There are going to be a couple more on Monday when we talk about how debt grows. And then I will give you a formula bank on your quiz when you take it on the block day next week. And then I'll give it to you again when you take your test for chapter 3, and then I'll give it to you again when you take your final. So here's so you've now created for yourself a chart. All you got to do is keep straight which one is which. So let's practice using these formulas. Okay, so let's assume James and Rachel each got a gift when they graduated middle school. All right, so let's pretend that James and Rachel received a $1,000 gift from someone, and they said, we want you to save this for college. All right, now James, he decided to take the simple route. All right, so James is going to choose a simple account. All right, James chose a simple interest account. At 4%. For 4 years. So it's 4 years of high school. So now he's, getting ready to graduate, and he wants to know how much money is sitting in that account. Rachel was a little bit more of investment savvy, and Rachel is going to choose the compound interest account. At 3.9%. And so James is like, I have a higher percentage than you. And Rachel maybe comes back and says, yes, but even though I'm taking a lower percentage, my bank is going to compound for me monthly. So I want to compare the difference between which sibling has more money at the end of 4 years as they look, to going off to college. So let's do James first. So because he's doing a simple interest account, we're going to do A equals P sub 0, 1 plus RT. And so for James, his P sub 0 is 1,000. His 1 plus His R is 4%, so we're going to put in 0.04. And his time is 4 years, so we're going to put in, multiply that by 4, and then we'll work that out. So, does someone who have a calculator out on their desk figure out how much James has sitting in his account? So this will be 1,000 times 1 plus, will end up to be 1.16. Okay, so who's got James's total? $1,160. That's just simple interest. All right, so let's compare that to Rachel's account. So she's using compound. So her formula starts out also with 1 plus, but her R is divided by the agreement she's come with her bank that they're going to pay her every month. And then her time is multiplied by those months as well. And so we'll put 1,000 in for Rachel. 1 plus, her 0.04 is going to be divided, no, excuse me, her 0.039. That's right, she took a smaller percentage. Her 0.039 is going to be divided by 12 because she's agreeing to get paid every month. And then her parentheses up top will be the 4 years times the 12 that she's agreed to. So when you type that into your calculator, some of you are going to have to be careful with how your calculator goes. My calculator will automatically do 1,000, 1 plus 0.039 divided by 12. When I go to my power like this, you see how mine jumps up to be that little square up there? I can do my 4 times 12 up there. If you have the little caret arrow symbol, you know, how many of you have that instead of having it look like this? Can I borrow yours a second? Because I know yours has it. Okay. So, like Isabel's has 1,000 times 1 plus 0.039 divided by 12, and then to the, she has that little caret symbol. If you have that, then you can't type in 4 times 12. You have to type in 48, which is what 4 times 12 is. Like, you have to actually work out the math first, because the calculator doesn't understand what you want you to do. If you have one like mine, you're fine to type in 4 times 12. Okay? All right. So Rachel has a whopping $1,168 and, let's see, 53 cents. So maybe Rachel will feel sorry for Jane, so she'll take her extra $8 and she'll take them out for Starbucks or something. Okay? This is just a small scale example. The difference because it was only 4 years. If this had been invested at their birth, so if they'd had 18 years, okay, you'd see that the difference would be a lot more. The longer time you have to sit in an investment account, the greater it will grow because it's accumulating interest faster. Any questions on that example? Okay, let's try another one. All right, starting with $5,000. How long will it take to double? Assuming that you're in compounding. If you compound quarterly at 5.25%. So a couple key words we have in here. First, that it says compound, so that clues you into what formula you need to use. Another one that says quarterly, which means how often? How often is quarterly? Well, it's how many times a year? 4 times a year. That's what quarterly means, okay? 4 times a year, which is going to be every 3 months. Okay, so this is going to be 4 times per year. And we know that it has to double. So the formula we're going to use is A equals P sub 0, 1 plus R divided by N to the Tn. So I know my initial is 5,000 and my goal is to double. So what does that tell me about my A on the other side? My goal is to double it. I need 10,000. All right. Then we're going to have 1 plus. The R is 5 1/4. Okay, so how do you turn that into a decimal? So again, let's take a look at that. Okay, 5 1/4 is 5 plus 1/4, 5.25. And then I have to move the decimal 2 places. So that'll turn out to be 0.0525. Okay, that's 5 1/4. And then the N is going to be 4 for the 4 times per year. And then we have T times 4. So we don't know what the T is. The T is what we're trying to figure out. All right, so we're going to divide by 5,000, both sides. That just gives me 2. Then I have parentheses, 1 plus 0.0525 divided by 4 to the, I'm going to put 4t instead of t4, but it's the same thing. Then I'm going to use my natural log in front of both sides, which allows me to pull my 4t to the front. So 4t will now be in the front of the natural log of 1 plus 0.0525 over 4. And the natural log will be in front of the 2. So I'm going to divide the big natural log that's on the right side over to the left. So I'll have the natural log of 2 divided by the natural log of 1 plus 0.0525 over 4. But I still have that pesky 4 in front of my t. So I'll have to divide again. Okay, so we'll do natural log of 2 divided by the natural log of 1 plus 0.0525 divided by 4, and then we'll divide that by 4 as well. So let's take a look at how that's going to go. So the natural log of 2, parentheses, divided by the natural log of 1 plus 0.0525 divided by 4. Okay, I'm going to hit enter, and then I'm going to divide that by 4. So the time is 13.289 years. 13.289 years is how long it would take to double that investment. Okay, any questions on that one? Okay, then last one. All right, how long will it take to triple an investment? At a continuous rate of 3 1/8%. All right, so the key word in here is the fact that you see continuous. As soon as you see continuous or continually or continual, you know you're going to use the PERT equation. And so this would be P sub 0 times E and then the R and the T. The 3 1/8 is your R. So again, if we turn that into a decimal on our calculators, that would look like this. 3 plus 1/8. Oops, 1/8. So that's 3.125. So move your decimal, and you're going to have 0.03125. So my E is going to be to 0.03125 and then the time. Now it might be a little bit of a puzzle now. What do I put in for P? There's no dollar amount. It doesn't say. It just says I'm supposed to triple it. Okay, so I'll let you in on a secret. It doesn't matter what you put in for P as long as you triple it on the other side. So we could have everybody doing different and it would all work out the same. So if I picked 10, what would I put on the other side? 30. Okay, that could be my choice. Someone else might pick, I'll pick 5. Well, then I'm going to put 15. Okay, I'm going to put 1,000,000. Well, I'm going to put 3,000,000. It doesn't matter what you put, because what do you do? What's your first step every single time? You're going to divide. And so if I divide by that 5, I'm going to end up with 3. And that will, no matter what number you pick, the division will always end up to be 3. That leaves space for you to use your ln on both sides. So we'll have ln of 3. The 0.03125 comes to the front. Now I have Lenny. And once I've got Lenny, I know that that can reduce away. And then I can divide by the decimal. So the time by itself will be the natural log of 3 divided by 0.03125. And that time value will be how long it would take any investment to triple. Okay, no matter the size of the investment, it will take this many years. So let's check what that is. It's a natural log of 3 divided by 0.03125. So we'll check that out. The natural log of 3 divided by 0.03125. So 35.156 years. Okay, 35.156, and that's measured in years. So look for the clue words in your homework. Simple, compounding, and continuous are the 3 different things. Choose the formula correctly, and then you'll have to show your math on both sides to solve it.